well, let's try that again. Good morning. Good morning. Just getting a little bit better. We still hadn't had our coffee and our soda and everything this morning, right? If you remember yesterday, I'm Miss Banister.
Miss Eckman.
Mr. K.
Mr. K. And today we're going to be moving on from what we've been working on the last 2 days. So we've been working on what topic? What was our big topic Monday and Tuesday? Density, good. And who remembers what density was? You remember? Mass divided by volume, very good. So we were looking at a relationship between the mass of objects and the volume of those objects. And density is an important concept that we're going to bring back up. Good morning, how are you, Caroline? We'll check you off in a minute. Where was Caroline sitting?
Autumn.
With Autumn? So Autumn, you want to jump up and sit somewhere else so you can sit with Caroline that way?
Yeah.
That'll work. Yeah, but we're partnering you up today. We're kind of making y'all change and put y'all in uncomfortable situations with people you don't know.
There you go.
All right, that works. We'll get you some paper. So we're going to take a different concept today, but I'm not going to tell you what that concept is. We're going to have you try and figure it out, okay? In order to start this concept, we need to talk about solids, liquids, and gases really quick. So if we have solids, liquids, and gases, we know there's a difference in the way that the particles act in those different states of matter, right? Okay, so let's see. Shannon? No. Michael. Go to the board and I want you to pick one of those three and I want you to draw what the particles would look like in that state of matter. Please. Thank you. All right, so Michael is drawing those really spread out. So Michael, you have the power of the pen right now. What I want you to do is I want you to pass that marker to somebody else and they get to do one of the next ones. That's what it means to be friends.
You're really friend.
Oh, what's that?
You're really friends.
See? Do they line up like that too? Okay, go ahead. I'm just asking. Yours are just in nice straight rows. That's really pretty. I like it. All right, so what's different? Explain to me why you're finishing between yours and the one that Michael just did.
Because the liquids, they're like spread out, but they're still close together.
They're still a little closer together than the gases, right? Okay, I'll let you finish drawing your chocolate chips in. All right, so guess what? You have the power of the pen for the last one.
Anybody want to go?
If you don't see me, I'll be
You know Nyla likes that attention. Oh, you got to think on this one? You know it's personal, girl. I don't know what you're doing with that paper yesterday. We're supposed to write down the ones that didn't show.
Are these somebody's glasses?
Mine. I'm too lazy to go up there and get it.
So what's the difference between the ones you're drawing?
They're tighter.
Compared to?
Tighter than what?
Who can tell me the difference between how these three things move? Okay.
The gases are spread out, like they have their own personal space. In liquid, they're spread out, but it's like they're close together. And then solid, like solid, they're close together.
Mm-hmm.
They can't move.
Okay, so they don't move, but do the gases and liquids, which one would move faster?
Gases.
They have a lot of room to move around, right?
Okay. All right, so now you've got a piece of paper, and we're going to use one side in here, and then we're going to use no, we'll have to split it up. All right, so what I want you to do on that piece of paper is I just want you to fold it in half, and we're only going to use half of one side for right now. Does that make sense? Y'all have paper? So basically, we're just folding in half, and we're going to use half of one side. Everybody with me? What I want you to do on this side, we've already got up here the 3 states of matter and what we think those particles look like, okay? I want you to draw a circle on one half, and I want you and your partner to discuss and decide what would oxygen look like. What do you think oxygen would look like? Good question. I'm not going to tell you that. I want you to fit the picture. Let me know what you think. What? Yeah. Does oxygen have water in it, or does water have whatever? I'll give you a little clue. You want a little clue?
Yes.
That's the only clue I'm giving you. So what do you think that would look like? I'm going to give you about 30 seconds. So in a circle, what do you think it would look like? So I didn't draw my picture yet. You only need to do one for the fair. You don't have to do one. So talk about, what do you think that will look like?
Well, you got, first of all, you got to think about what is oxygen. Yeah, but what state of matter? What state of matter is it? What state of matter is it?
What's that? Nyla? Well, no. I know you do. I could tell. All right, so let's get a volunteer. Let's see, who had the power of the pen last?
Jared.
Shannon. Power of the pen. You get to pick. Who's going to go to the board and show us what they drew? And I'll give you the marker. So you have the power of the pen.
Me.
You know, Nyla's dying up here. This is terrible.
Wow. I got my hand.
I know. See? Oh, what? Oh, go Hannah. Go Hannah. No, not happening.
It's my birthday.
Is it? Really? For real? Happy birthday. We'll light some fire for you later today. You don't think that's necessary? No cake. My niece always says you can't have a birthday unless you have cake.
That is so
I'm watching. I'm wanting to see where this is going. That's just looking like it's some creative artwork going on right there. Why do they all have arms?
Because it's like a left apart, but not literally not together. But it's together, but not.
Because it's a what? What are you telling me?
It's a liquid in there. But it's
It's a liquid and a gas? You're scaring me. I've never seen a liquid and a gas all at the same time.
It's a gas, but it's mixed with something.
It's mixed with something. Okay. So are they're holding on to each other? But they still got enough room to move around. Okay. Anybody have a different drawing? All right. You get to pass that pen to somebody's got their hand up. And we can draw it next to it. We can draw a different one. It doesn't have to be as big or anything. All right. So we got Garrett coming up.
Maybe you can use the green color.
Yeah, that one's not working good. That's cool. Yeah. Wait a minute, you don't have any hands holding. hold on, why is yours different?
It's compounds.
What?
O2, the oxygen gas in our air is not the singular oxygen atom. It's actually a compound of 2 oxygen atoms.
Is that what the 2 means? Yep. So, wait, is that the same thing as what Hannah was saying with the holding hand thing going on?
Sort of, except that it's more like O6.
Why?
Because they're all a lot more.
Okay, all right, so is there a difference? All right, do we have a difference? Still a different? All right, Gaines has something different, so why don't you give Gaines a shot at it? Let's see what Gaines comes up with. What, why? No, there's no quitting in science. If you quit, you know we probably wouldn't have light. Who was it invented light? If he quit, do you know?
Draw a different circle.
Yeah, you can draw a different circle.
Draw a different circle. There you go.
Look at this. Draw a big one there, Gaines. He got big chocolate chips in his cookie. They're green. They're not spreading. Just 2 separate. They're not holding on to each other. Okay? All right. So let's kind of come back here. Thank you, Gaines. Good job. No, I'm sorry. No power at this moment. But I'll give you some power a little bit, okay? I know power is important. So let's raise our hand if we agree with Hannah that we got friends holding on all over the place. Okay, Hannah's got some people with her side. Let's raise our hand if we think Garrett's right. We got 2 holding on each other.
He explained his information.
What? What'd you say?
He explained his information.
What do you mean he explained it? Hannah explained hers. His was more scientific. So what is it that Garrett said that convinced you, Austin?
He explained it like step by step, like he added to
Is it because he said this word? Is that it?
Yes.
So what if I threw out some big crazy word that you never heard? Would you agree with me?
Yes.
If it's a word that I've heard of before.
No, wait a minute, we got one more. Gaines. Who agrees with Gaines? Okay, so it looks like we're all on board with Garrett, and Garrett's right. We would actually have 2 molecules of oxygen that would be next to each other. And of course it's a gas, so we know that they're spread out, right? Okay. So what we're going to give you now is we're going to give you picture cards, okay? And you're going to need to look at these picture cards, and what we want you to do with your partner is we want you to decide that argumentation and defending yourself is going to come in handy here. What 2 stacks should they be in? How can you separate these into 2 groups? And I want you to think about what are those 2 groups, okay? But remember, all you got some pictures. I think we had these all sorted, and the paper clip came off, okay? So this is going to be tough. I want you to think. You have to look at all these pictures and see what you've got going on in your paper clips right there. So we have 8 stacks. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6. Make sure you only have A through I. Make sure you only have A through I on your cards. You don't need 2 A's, 2 B's, 2 C's. Do we have enough?
Yeah.
Okay, good. So take a look with your partner and think about how can we sort these into 2 groups, and what are those 2 groups? Why are we sorting them this way? I like how Nyla's got theirs laid out so they can see all of them and really look at them. Right there. If it's shiny, I'm sorry. I'm really proud of you. That's really awesome. This game's so right there.
So do we like break them?
So you have to sort these into 2 groups. How can we sort these?
She didn't tell us that.
I don't know.
It's just one straight arrow.
Does it look like it's just one or the other?
Well, it could be like ones that
But is it just one picture on a card? No. So what does the arrow tell you?
Oh yeah. Big circles. condos like
Oh, so maybe something that's happening. Okay, so look at all your pictures and decide, how can we group these into 2 groups?
like mixtures.
Maybe.
Maybe there's this.
Ones that, this would be like a mixture.
So look at all your pictures and think, how can I sort these into 2 groups? Which the problem is you've got this arrow on there, right? It's not just one picture on a card. What does the arrow mean? What's that tell you? What's that? Combine? What's an arrow tell you when you see it on the street? Which way you're going, right? So that's where you're headed. So kind of use that and think about how can you sort these into 2 groups. So you got to really look at these pictures and study this. Sure, absolutely. What's that?
Where?
Okay, so you have 2 groups. Have you talked about it with, who you got, Michael? We kind of talk about it? Okay, so hang on to that thought for a minute.
If you were going to title them, what are you going to title the 2 groups? This pile is for this pile.
No, we had another one.
What are we looking for?
It's just for today. Well, it might be tomorrow. Stick with me. Stick with me. You can do this. All right. All right, so coming up.
Remember, when you're making groups, you got to be able to tell me why you put them in a group. You got to be able to put a label on that top of the group. You got to say, you know, it can be whatever, but you got to be able to tell me why. Not.
Are they supposed to be like
Oh. Okay, so talk with Hannah about that. Is that different in all the pictures? Did you hear what she said, Hannah? So,
All right, what do we decide?
come on now. You was brave enough to go up there and put the hand on it. And I'm proud of you for that. Thank you for sharing your idea. It's okay to be wrong sometimes, right? But you had the right idea. You just had too many friends to get. You only got 2 ways to take it. All right, so talk it out and decide 2 groups. No more than 2. Okay. So wait a minute, show me which ones don't have any positives.
So what do you think all this stuff is mean? Were you in 7th grade last year, or are you going to 8th grade, or going to 7th grade? So does it look like anything you studied in the 7th grade?
Okay. You're okay.
Were you going to 8th grade?
So what kind
Does it look like something you studied? Molecules? Okay. What does this look like to you? What's something you studied?
Oh, okay.
Keep going. A little smaller. Okay.
Okay, but remember, only 2 groups. So our groups are the differences in closeness.
What do
If we're
arrows
taking apart or putting together. Okay.
I like top of your head. Alright, so if you think about that,
You got a question. What's up?
Yes. What's happened?
We're trying to figure out this is be like
What's the difference in those?
a mixture of something like this.
Does it look like that's happening in whatever? Look at this. What's happening here?
Solution and stuff like
Start with this.
doesn't seem like you.
You said this stuff. What was it? And then but look at this.
You got to I need
So let's think about ones where they kind of maybe look.
All right, let's give it about 1 more minute. Try and wrap up your 2 sets. I'm worried because I see Gaines that has 3 stacks over there. 2 Gaines, 2. Okay, all right. You can't have 3. 2 stacks. Y'all come up with an idea? Do you know what you're going to call your 2 stacks?
Alright, what do you think that is?
I thought it was, FEMA chat word.
Yeah, but that's coming from a what?
It is so green.
Alright, so that's your thinking for that. Alright, what about those?
Well, I thought it was, the difference would be things that were just changing, like they changed from something to something, and FEMA, like they're combining, like it's different things.
Okay, alright, you're on the right track, I believe. Yep.
All right, we ready? All right, Nyla, tell us what your two groups were. How did you group yours?
Hours by mixtures and solutions.
Mixtures and solutions.
That's the word.
Woo!
I believe it.
Who said that? Who had an epiphany?
Austin.
Austin. All right, help me. Michael? No. Shannon? No. Shannon's back there. You're Michael. Okay. I'm going to get these names probably Friday. All right, so Michael, what were the two groups y'all came up with? Okay, so complicate that. Hey, don't laugh. We don't.
It was group A and group B.
Complicated and simple. All right. Shannon's group.
Changes versus combining.
Changes versus combine. Okay. Garrett, what'd you guys come up with?
Which was similar, it was ones that just simply changed their state of matter, and the one that had two reactants that combined to either make a mixture or a compound.
All right. Change in state of matter versus, what was the second one? Show again.
Ones with two reactants.
Two reactants. Okay. All right. Hannah's group. Positives and negatives.
Are those the two groups, or is that those two groups?
So yeah, she has a positive group and a negative group. Austin. Solutions and non-solutions, okay. Was non-solution supposed to be mixture?
What was it?
It's okay. All right.
Anything?
Gaines, what'd you guys come up with?
Anything's fair.
Solids in one group and liquids.
Solids in one group and liquids and gases in another, okay? Solids, liquids, and gases. Okay, and Caroline and Autumn.
So we did more compact and less compact.
Okay. I don't see anything that's the same up here. We all came up with different ways to sort. That's okay. We need a little bit more information, don't we? Okay. So I'm going to give you a key, and this is going to help us a little bit. Before we do, let's talk about a word that I think Garrett said. He said reactants. And you see on those cards, you see the arrows? I think I went in a couple of groups and we talked about what does that arrow mean?
The direction.
What do you think that arrow means? Equal. It's pretty much an equal sign. So that's what we're going to get, okay? So that's the result of something that's going on, okay? So we're going to give you a key, and we're going to let you look at this again and see if you change your mind on your groupings and how you have them grouped. Short one, I think. We're missing a card. We're missing the card. No, not yet. I don't know, how can we have 8 sets and not a card? Alright. I was going to say, do y'all want to turn your desk and share, because for some reason we're keep short. This was not our set of materials, sadly. So we're going to give you about 3 minutes and see if this changes your groupings.
Orange atoms are iron.
That's not on that key. Where'd you come up with that? Where's water? No, on your picture. Okay. So the two little white with the red.
So what happened here? You started with.
Okay.
Alright, so what do we say?
Okay.
Alright, what about
So does this change your
here?
grouping?
You started with.
It does make you think about it different, doesn't it?
There's something there to
In a different grouping, so some of the cards may have changed. Okay, all right. So the key didn't change your mind.
Here to here.
do we want to put that arrow?
I didn't want to go too far.
Real quick, I don't know.
I didn't clarify.
Just to clarify, this arrow right here means yields or producing. So basically, one is going to something else, or
It might be.
maybe not. But that's what that arrow means, yields or produces.
Chlorine can be a liquid, but chlorine also be a gas.
Alright, so do you see any of this right here?
So I've really thrown you for a loop, right? I've given you some information. Hannah, any thoughts?
It's a solid.
What do you mean groups that are mixed up? If that's what you think, then this information.
Is there something new up here, or is it Alright.
Y'all gotta talk it out. Don't have much longer.
Alright, so what are we looking at now?
Change
We're what now?
So then here, we get the we get the snow.
Ice going directly to a gas? Alright, so what do you think's happening here versus here?
So something else change anything? Which was your grouping? Solids, liquids, and gases? All right, so did it change anything? So now you got a whole different word now.
So what are you saying?
Because that's not a solid liquid gas. Ain't throwing little things together, right?
Okay.
Very good.
But look at what you're getting when you start. Look at what you have when you start. What's different in this one than this one? Okay, it's more compact, but there's something else. What else do you notice? This didn't. When you say they're more
This is
compact,
solid copper, now solid copper.
they're all what?
And this is,
You remember what your picture didn't do when we were up here?
okay,
What did it not do?
What are some things that this kind of looks like?
okay.
They weren't touching, right? So what do you notice here versus here? Okay, so tell me, you got two little whites on the red, right? So what are the two whites? The word hydrogen. Red is oxygen. So you've got H and two
But
O's.
be careful, that's not copper.
H2O.
Tire.
And we know.
H2O. What is H2O? Water. So you've got water here, right? Do you still have water in here?
Have you ever seen these before? No. Why does it have a carpet charge rate?
Is it carpet? Really? Is it?
Carpet water.
So now, you've gone from well, excuse me, you went to a solid to a liquid. So what happened? You what? What do we call it when we go from a solid to a liquid?
This is actually
We change the state. What's that process? What do we say when I have ice and becomes water? Not ice what? Nothing. So I got melting, right? Okay. So this is showing melting.
That's still both, but it's just like
Combined to make that. So we got some, what is the gray? We got some magnesium and we got, and they combined and we got, you know how you would say that? You just, I don't know. Magnesium.
You reason it one out.
All right, so let's come back together. 5, 4, 3, 2, 1. Did anybody change your list? Okay, Austin.
We had chemical change.
So you had which one? You had this one?
Yes, ma'am.
So now you're going to what?
Chemical change
Oh my. Chemical.
and
Okay, that's completely different from where you were. All right, Hannah, what'd you guys come up with? Were you guys positives and negatives? All right, what's your grouping now?
solids and liquids.
Solids and liquids. So you went
Solids and gas.
solids with gases?
Solids and gas.
Solids and gas. Okay. All right, who else changed? Autumn. Cheyenne. I'm sorry. You're talking, you're not hearing. Producers and non-producers. Okay, who else had something, a different category? What'd you come up with?
Liquids to gases to solids.
Liquids to gases and solids, okay? Liquids to gases and solids.
All right, we got one on there.
Okay, Gaines? Compounds and solutions? But they changed their thinking on it. Did y'all have a different one? What'd y'all come up with? So you went to the liquid, solids, and gas. So it was liquids and then solids and gas? So you grouped solids and gases together?
It was solids, liquids, and gases.
So we got solids over here. That, right? Okay. So we changed our thought, and some of us changed to things that were already on our first list, but we've got a couple of new things. So I see, let's see, compounds were not up there earlier. Chemical and physical weren't up there, and producers and non-producers. Who said producers and non-producers? What does that mean? What do you mean by producers and non-producers?
That when we mix them together, they're going to produce something, or they don't produce something, or they lose.
Okay, so we get something new or we lose something. Okay, okay. Where's my chemical physical guys? What in the world do you mean by all that? Yeah, you're going to have to do some explaining here. Come on.
Oh, we got to go up there?
No, but tell us. You need to tell everybody. What are you talking about, chemical and physical? Okay, so everybody look at card C. He's pointing at card C. Look at card C.
Like in the bottom circle, oxygen and gas.
Okay, so in the bottom circle, y'all hear him? He said he's got oxygen gas,
And then the top one is
magnesium in the top.
and then the oxygen gas is turned into just oxygen. And so that'll be
It's no longer oxygen gas, so we got something new, all right? Tell us a physical one. Where's the physical thing?
like on card A.
Go to card A. Take a look at card A. Yeah. Take a look at card A. You gotta speak a little bit louder, they can't hear you.
The bottom circle,
Bottom circle,
H2O,
which is what? Water.
and we look over in the big circle, there's still
Still water molecules, right? Okay.
and then in the south circle,
We got what? Some carbon,
is hydrogen and oxygen.
carbon, hydrogen, and oxygen.
And we look over here, you can still see it.
We still see it.
There's nothing changed with it.
Okay, so nothing changed with the physical appearance. Okay. Well, good thoughts, good ideas, but Austin's team is actually heading in the direction we want to go. Okay? We actually could group these in a physical and a chemical difference. And it goes back to, I was talking with Gaines earlier. Which card was that? Do you remember? Was it that card? The one we had water? Remember? So what letter is that? Simple one to look at? H. Simple one to look at is H. If we look at H, we see that we have a lot of really close together H2Os, right? So they're all holding those hands like we were talking about before. But in the picture after the arrow, after the yield sign, what's different about the H2O? They're spread out. So what does that tell us with what we knew with solids, liquids, and gases? It changed the state of matter. So we went from a solid to a... So did we get anything new? We still have what? Water. Okay, so here's what I want you to do. On that other half of the paper where we folded that piece of white paper, I want you to make just a column. So here's my paper. Here's my fold. Just kind of in half, I want you to write physical and chemical. And I want you and your partner to discuss what do you think that is, and give it you can either write a sentence, a definition, you can do a picture for each one. How would you describe what you think a physical versus a chemical change is? So talk with your partner. That's all those people that sit next to you.
About physical.
Yeah, you can draw a picture, you can describe it. I'll just copy one of the picture cards now.
So this would be chemical.
So how can you describe that? How would you define
The appearance of the molecules themselves don't change. You can still see them separate.
Okay, so let's put either something in words or put something in a visual. You agree? Are you giving any input? You're just being so quiet. Come on now. I gotta hear your thinking waves too. I can't get in there and like pull them out, right? Okay. If I could, that would be bad. That would be. I don't want to pull anything out of your brain. So discuss. How are you going to describe that? What do you think that is?
What's going on? Think of the word change.
Why?
Because it's
not like you can't go back into the same.
That's what I want you to make sure that you
Look at your
put somehow as words or
pictures.
visuals.
See which ones you
Okay?
think.
All right. Good.
Okay, what do you think that one is?
Go ahead. Come up with something.
Do you think that's a physical change or
You can't get blocked back. Same as if you get a haircut and you don't like it.
what's that?
To be hair.
It's water. Right? What's that?
So you give me an example. Good. All right. What's
Water goes to water. So did anything change?
So what's the difference?
Did you get anything new?
What did you think about your cards?
Okay.
What did you say?
Okay, so what am I trying to get at? What happens during a physical change?
So I get something.
Nothing really changes except maybe appearance or something like that. Okay. Let me ask you a question.
Say that again.
Tonight, your parents say you need to
Okay,
go
can you
mow the
describe
yard.
what it
Cut the grass. After you cut the grass,
Okay, help me out.
So did anything
So
change?
things like before and after.
No, so that would be a what?
Before these change, you have
Okay, but now think about a chemical change.
and then after you have a cola. So it's still, no, it's still what? You have ice cream, and then it's still ice cream, right? Yeah, so you have ice cream, it changes, and then you still have ice cream.
So what do you think?
But what about chemical? What's the difference?
So I'm saying if you burn wood and
Look at your cards here. So if we were listening up here to what Austin said, he said that when he looked at some of the cards, he started with one thing, and then what happened?
So again, something like totally.
Not a state of matter, because if you start here and think about this, you start with what? What is all this? This is water, and then this is, right, so is this technically still the same thing? Same thing with the ice cream. You have ice cream, then it becomes melted ice cream, and it's still ice cream, right? So a state of matter is another example of,
But in a chemical,
so you can write state of matter. What about if I go and have a haircut? Does it look the same if I get a haircut? And then, but is it still hair? Yeah. So it's a change in physical appearance, right? So it looks a little different. But chemical, which of these would you think are chemical changes? That one's really hard. Let's not look at these. He's kind of an outlier. Like it's a little bit of an exception. So is this chemical?
so you're going to draw that line, right? All right, let's be wrapping up with our thoughts on physical versus chemical. Because we're going to do some exploration in the lab on this idea.
Start with this. And this.
I know, but you did.
Did anything change?
Oh, yeah.
You were putting a lot of vocabulary terms. What's that one? Okay. Okay. All right.
And do you have water over here?
So you're using some
Okay.
adjectives.
And then this is
All right,
something.
if you'll take the picture
You
cards
still have it over
and
here.
stack
So
those
this
back
is-
together for me, and if you have a paper clip them, please.
Yeah, put them in order for
Yeah,
us,
that would be
please.
super
A, B,
great.
C, D, E, F, G, H, I.
Mr. Phil had to work really hard to do that yesterday.
Yes, I was
Mr.
having.
K.
Yes.
And put the atom key on top. Put your atom key on top if you have one. And did y'all have paper clip? It was right there.
You don't know if you had paper. She'll leave me to go to the hospital. You don't know if you have paper.
I don't know, you're sharing.
That's right there. Is that it?
So what we're
Or
gonna
did
do
we
now
dismantle the
is
paper?
we're gonna head down to the lab.
Dismantle the paper clip? We did.
Oh, do me a favor, on the top of your paper where you're writing your ideas, put you and your partner's name, because we want we might have to work on this a little bit tomorrow too, and we might take it up from you so we don't lose it. So make sure your name's on your paper.
So you're gonna eat the tape too?
Do we want to
Promise?
bring that, do we need to bring that? Yes, we need to bring that paper to the lab. Okay, so we're gonna bring that piece of paper with us to the lab.
Are you just going to do that in the back?
What's that?
Or you need a separate?
We can do it on the back. You mean the dad at the table?
Yeah.
Yeah, we can do it on the back. Okay. Come in here before we go.
Tell them as soon as they get to the lab.
Okay, okay, all right.
All right, folks, I need your attention. Yesterday when you were in the lab, there wasn't any, you had to wear your goggles, okay? Today, you must wear your goggles. All right, we are working with some chemicals today that if you were to get them in your eye, could.
You're not gonna die.
No, but you'd be going to the eye doctor because, is there anybody that's wearing contacts? If you're wearing contacts, okay, it's usually recommended that when you go to the lab, you do not wear your contacts, you wear your other glasses, because in some cases, now the chemicals that we're dealing with aren't that bad, but in some cases, if you were going to a chemical lab and you got the chemicals and you forgot to wear your goggles, the chemicals could actually, and I'm not trying to scare anybody, but they could get underneath your contacts and fuse the contacts to your cornea. And eye doctors don't like those kind of situations. So as soon as you get in, the goggles have been wiped down with alcohol to prevent, well, to kill any germ, because all you guys did yesterday was take the goggles and just stacked them up, so you're not going to get the same goggles you got yesterday, so we had to clean them. So as you get in there, you are going, there's several stations. Are you assigning them
Yes,
to
We're
stations?
starting with the demo that I'm doing.
All right, you're good.
But they're gonna have to go to stations for the demo, yes.
And I'm doing a demo.
Yeah.
Okay. All right, but as soon as you get in there, the goggles have to go on. Have to go on. Okay? And if, I'm going to be honest with you, if I see that you take your goggles off, I'm going to tell you to step to the side. And if I have to ask you more than 2 times, then I might have to tell you that you're not going to participate. Because safety in the lab always comes first. Does everybody understand that?
Thumbs up if you got it.
Everybody? Okay.
All right, so we're gonna line up. You need your paper,
And everybody knows
your
their part.
pencil, and stick with your partner, because
That's your friend.
you did great. Don't lose it, but we'll come back.
And then we actually took one of the stations out, station 5, because Mr. K is going to do that one as a demo too, because we didn't want you guys to have to handle a blowtorch. So, I know. So, but thinking about kind of, I know we may have forgotten what we were talking about on the walk down here. So remind me, what are our 2 things we're going to be looking at today? What game? Physical and chemical changes, right? And so what was the definition that we may have kind of started? What's a chemical change? James?
Something like you have a piece of wood and you burn it, not wood before it's
All right. What's a physical change? Someone else. Garrett, I saw your hand.
Anything that changes the physical properties of an item and can supposedly be reversed. Like
Supposedly be reversed, okay.
You chopped up a wall.
All right. Michael, put you on the spot here. What's an example of a physical change?
Ice cream cone, melting.
Right, because before you have,
It melts.
before you have ice cream, and then after you still have, right. All right, so thinking about that, on your paper from the other class, you have your definitions of chemical and physical change with your partner. I'm going to do a quick demo here, and after we do the demo, you're going to refer back to it or go back to it and kind of add to or modify
Watch what she's doing.
your definition. So right now we have what? What is this?
Paper.
Paper, right? Right?
And now it's burning.
Right, so after we have the burning, it's going to be, it's going to be,
Ashes.
so we don't have, so this is a, correct. Now, then we have our, this obviously is no longer correct. So that is a chemical change, like you said. This right here is
Paper.
and now it is paper. Pieces of paper, but it is still
Paper.
just like ice cream before it melts is still paper, or ice cream before it melts is still ice cream. Go back to those definitions, take about a minute, maybe change, scratch out, add to, modify what you put on that definition.
Add or change anything to your definitions or your visuals. We're good with what you got. Okay. If you're going back to those definitions or pictures we did for physical and chemical, and if you want to change or add anything, this is a good time to do that. Mr. K's, you know, got that.
All right.
She just changed it.
Okay. I'll do that.
No, it's one of those things. Change it up till like.
Oh, okay.
Well, we didn't change the paper, but the paper's so big.
I'm not like that.
All right.
Are you recording?
That should not have taken you long. All right. Turn your papers over
To your full blank side.
to your full blank side. All right. We have what? 9 stations?
9 stations.
You got 9 stations. Okay?
Oh, 10 stations, sorry.
No, but that was,
Mr. K's in that station.
Yeah,
that was
that's
the
right.
rip and
No, I
burn.
Took out number 5.
All right. What we want you to do is we want you to make 4 columns. In the first column, you're going to put station 1, station 2, station 3, station 4, station whatever. Then it's going to be a data table. Leave yourself enough room. You're going to say what you observed. then you're going to say if it's a physical change or a chemical change, then you're going to have to explain to us why you chose that. So go ahead and make your table.
Okay, that's fine. You can go ahead and underneath use it.
You want to do it the long way?
So go ahead. Your whole page. You're gonna have, you can number 1 through 10 stations, because Mr. K's getting ready to do one of those stations with you as a group.
I am doing station 5 for you as a demo.
So you can number down
And
1
when
through
I
10.
show you the demo, you will understand. I will explain to you in detail why I'm doing it a demo.
No, we have no
Okay. Make sure you label your comments.
Give yourself enough room for your observations.
Preston, you good?
Basically, in the column that says physical or chemical, have a small column, and all you have to do is put a P or a C.
Yeah, because P means what? Physical. There you go. What's poor C? Sound like the C don't have no money.
Yeah,
Hey, bro.
I thought it was like pork. That's what I said, like horse. I didn't know what it was at first.
P not poor, neither is the C. Neither one got money. Can you feel the C, girlfriend?
All right, about 10 more seconds to finish up.
Don't forget
You did
six.
number your stations, so you got to number down 1 through 10. Because you're on top, different stations. Guys, make sure you number 1 through 10 on your station numbers, because you're going to kind of hop through different stations.
Can we like split them? Like,
All right, if you look at the agenda up here, you see the word expectations. All right, in a lab, the expectations are no horseplay,
Get to 11. What time do you have?
no fooling around. What about goggles?
10:21.
Goggles must stay on, okay? And we're respectful. And we observe, okay? So, procedures. Here's what we're going to do. I'm doing number 5, okay? So you will not do number 5. I'm going to do number 5 one time, okay? Then, you're going to come, and the way it's going to work is on some of them, you will have one of us with you. On some of them, you can just do on your own, but the ones that are a little bit more dangerous, okay, example, station number 1, Ms. Eckman will explain to you why it's a little bit dangerous because of the chemicals, okay? All right, so, does anybody have any questions as to what we're doing? Anybody have any questions as to what we're doing? Is everybody in their proper groups?
So do you guys see that, like up here on the board where it says number 2, move to an empty station when you're finished? So if Nyla and her partner finish, they can move to an open one, but you can't move there if another set's already there. So for example, she finishes here, they finish, and they're like, okay, well we're finished, we're gonna move to one we haven't done. There's no one here at station 10, so they're gonna come over here and start. But they cannot move to station 3 because there are people here, okay? You can only move if the station is empty.
So basically, there should only be 2 people at any station at any time.
There you go.
And extremely, extremely important to read your directions, especially when it comes to discarding any kind of chemicals.
That's what these speakers are for in most cases. Right. Any questions?
Do you want to talk about the hydrochloric really quick? Are you going to mention that? Because we do have it back here. And they got a, yeah. So some of you have on your card, and I think it's at station 6.
Which is right there.
Guys, you got to listen because this is really important. If it says HCl, we know H is hydrogen. Do we know what Cl is?
Chlorine.
So it's it's hydrogen chloride. So that's kind of dangerous. And what it does is it's an acid. And so it eats up materials. It can eat through calcium. So you definitely want to be extremely careful and not get that on your skin, okay? If you spill a little bit, you want to let one of us know so that we can come take care of the cleanup on that. Definitely do not pour that down the sink. That needs to go in the discard beakers, okay? If you have a discard, then that would be it, unless it tells you to use that for something else, okay? Does everybody understand with the hydrochloric acid? That's really, really important. Now, let's also talk about turning on the sinks. Yesterday we had splashdown going on at some of our stations. When you turn this knob, you do not turn it as hard as you can. You turn it just a little bit to get it running if you need to get water. You do not need to turn it wide open. Also, with some of your instructions, it tells you to measure out 2 milliliters into a test tube. You have a test tube over there. 2 milliliters is about, look over at Miss Eckman, it's about that much. You don't need very much to make 2 milliliters into your test tube, okay? But there are not measurements on your test tubes. Does that make sense what we said there? Okay? All right. Any questions?
Also, you have beakers. Did you talk about
yes,
this?
the discard.
Oh, you've already talked about it.
All right.
I need everybody.
We'll move you two
I need everybody to at least be able to see this. Now, I have 1, 2, 3, 4 people in here besides myself who are witnesses to this statement. And I always have to say this statement.
You move back one.
What I'm going to be doing here is I'm going to be setting a piece of magnesium on fire. If somebody could get the lights for me in the back, it does a whole lot better.
Now listen, this is extremely important what he's going to say.
When this thing starts to burn, you must not, keyword, not, look at it directly. It gives off a bright light. In some cases, if you have very sensitive eyes, it could hurt your retinas. You know what your retina is? No. It's where the light focuses to send the impulses to your brain. Okay? If you do something to your retina, it could cause eye problems. When this thing starts to burn, what I want you to do is you look to the side. So when it starts, just do not look at it directly. Does everybody understand that?
Yes,
sir.
Is there anybody who does not understand?
Yeah, you look
Alright.
That's not looking at you.
I have 4 witnesses, so don't come at the end of the day and say, oh, my eye hurts. Because, hey, I am giving you fair.
And this is going to burn very quickly. So as soon as he
Burn
touches
very
that flame.
So Mr. K, is this because it's burning, is this going to be a physical or chemical?
Wait a minute,
Well, they're going to have to determine that.
Oh, okay, so that's
So
what we're
this is
thinking
which
about.
station?
This is station 5. So you're, excuse me, you are recording station 5 first. Okay?
You're looking sideways, look sideways. Sideways.
I'm not about this.
All right, I will.
Don't cover your eyes now. You want to see something, you just want to see it out the side of your face.
Oh my God.
Out of the side. Wait, nothing's happening. It'll happen in a second. You'll know.
I can see him on the side of her eyes.
If you can see the side, it's okay. You just don't want to look directly at it. Do not look direct.
I'm not about this though.
They're not even, this person has even with their eyes closed.
Is it not lighting?
Now it's not lighting. Today it's lit.
Can we look?
That's great.
That's not.
Come on.
Observation.
It's not light.
Oh, it's light. It's light. Turn away.
Well, it's not lit yet. That's just the flame.
Oh.
That's like the birthday cake flame.
This is a birthday flame? Yeah.
Don't go look.
Yeah, whose birthday
It
was
was
it?
Cheyenne's birthday.
Cheyenne, there's your birthday. We'll sing.
Happy birthday.
You just don't get to blow out anything.
There's your birthday.
It's your birthday present. It's going to be outside.
So that is.
Why is it not?
Yay, I'm gonna go
Go tell her I need that torch.
Oh, we do it again.
All right. You don't think she brought it?
No, she bought it. She just.
Okay. What we'll do is we're going to come back to this one at the end because we're having difficulty. We're going to see if we can go get the torch. All right. So go ahead to the station you're at. Remember, station 5, you're going to skip.
Carefully measure.
So go ahead and follow your directions. Just be really, really careful with that HCO.
Alright.
Are we not allowed to have it?
Hey, you can go.
Yeah. Real careful.
Alright, so what am I supposed to do?
Using a transfer pipe and graduate. Carefully measure.
Okay, so remember, we don't want to lie. 1.5 millimeters.
Hydrochloric acid.
Yeah. 1.0. Hydrochloric acid. Yeah, pour it into a small test tube. Measure at a 0.1
Magnesium.
Yeah, magnesium.
So we're taking this to
and place it.
You don't have to use this.
Yes, sir.
Magnesium and paste
Yeah,
it.
plan what happens. Yeah. Alright.
You're saying about watching Possible Alert, so what's it say?
Alright, so there's our hydrochloric acid.
No, not water.
Our magnesium. What number is this? Magnesium in.
No, it's already
Feel it. You can feel the test too.
So you're making observations about the name. What do you observe about the name?
It's in that water. Alright, keep using it.
Okay.
See? Alright, so you're making observations. Session 1.
To the next station we go.
Are you okay?
And you put magnesium in there.
What's our direction say? Using a transfer pipette. Sorry, graduated cylinder that's breaking it down. Okay, so we're going to say around 2 milliliters of hydrochloric acid.
Then,
Alright, hold on a minute. I'll be right back.
is this going to be a physical or chemical change? Okay. And we're going to these bubbles, they create a gas.
10 is what she showed you, and that's what I was going to show you. But I've got to go get some hydrochloric acid, and I'll be right back, okay? So is it physical or chemical? B or C, okay? I'll be right back.
Oh, we didn't put hydrochloric acid in the station.
Why you guys can't do it? Because the gas bubbles up, and when the gas hits the actual fire. Alright, so why is it a chemical change?
Because it can't come back. The magnesium can't come back from the acid.
Okay. And it's still going, right? You can still see that. What's it doing to the magnesium?
It's breaking it down.
It's breaking it down. You gotta wait for Miss Banister to get back to that one.
The nail is still
How long is it in a bubble?
Until the magnesium.
That's the restroom.
Yeah, until the magnesium's gone. Once that little piece of magnesium's gone, it'll stop bubbling because the chemical reaction is going. So another thing that tells you a chemical reaction is going on is that heat coming off. Because heat's produced during chemical reaction. That's what's happening.
Alright, that's me, so I'll be there in just a second. There's no more.
What's over here?
Okay, so what happens to the top? Okay.
It says using a transfer pipe and
You don't have to. Hello, Gary. Alright, so what am I supposed to do?
So in that this tube, well, yeah, measure temperature. What is that?
A 1.0 mercury.
It's a chemical.
Oh, you don't have to do it. Are you up to it? No, yeah, you don't have to do it.
But if I do this,
Oh,
yeah. So write that down.
I have to. So what do you make it? Because I'm going to put hydrochloric acid in here.
Just look at it.
I'm just doing normal. So what am I going to do with this?
Yeah.
vibration is that magnesium ribbon.
Just the water.
And place it in.
Yeah, don't put chemical on a fire.
All right, you want to drop it in?
You can make that one.
Oh, it doesn't.
Now somebody can hold it if you want to for reverse hydrochloric acid. Somebody probably wants to touch down there because what happens during chemical reactions, you can feel wet.
So let's do this. We're gonna pour this and test it.
Feel the heat right there.
Okay? So I'm gonna pour this.
Oh, yeah.
All right. So what do you notice right here? What are some observations? What's this stuff up here? And scientifically, it would be what? Yeah, evaporative particles are gas.
Why? Because it's the same. The water is the same as this one.
Popping.
Don't get crazy now.
Now listen.
So what are we doing? Watching? What's that?
I was prepared that time.
You're prepared that. Exactly.
Alright, what do I
Yeah,
need to
and it continues. So right now, can actually bubble. Until what? Yeah, until what's this in here? So that's what carbon. Yeah, until the magnesium's actually dissolved. Station 1. You want to fill this out, give us some observations you see.
So this is the same thing.
Michael, did you get the bin?
Which one?
Oh, never mind, I got it.
Alright, so this is what this
And what are some other observations you made?
But the question is, if I put salt in water,
Which creates speed.
you get salt water.
And what did you notice about the way it felt?
Alright, and then what if I do this?
Okay, so it's releasing.
So that's number 2.
If I get the salt back,
So is this a, yeah?
That's what I want you to do.
Because it's not magnesium.
Right, because it's a new substance that's formed, correct. Make sure you're careful. All we're doing over here is observing.
Are we at 10 minutes?
So we're just watching it.
10:44, just watching 6 minutes. Can you
And
do
telling
this?
what happens when you see it.
There's people here.
while we work in the morning now.
Alright, they both are over there?
All right. Alright, come on over.
Alright, who wants to help? Alright, we got this.
Right here. We have hydrochloric acid, 3 during your
We'll do this last.
Measure a
Careful. Over here, just observe. Now look at it.
It's boiled.
Yeah. Make observations. Okay. So we have hydrochloric acid, and then we're going to drop, what is this? Magnesium in here. What do you think is going to happen? Make some predictions. Melt. You think it's going to melt? Demolish. Steaming? Using chemicals? But it's melting. You said melting. Is melting a chemical change?
No, not the same thing.
What's going to happen?
Broken down.
Be broken down. All right, I'll take that.
What am I doing? What am I getting? This is
You
what?
can hold it. Be careful. The
What
hydrochloric
kind of a
acid.
change?
And you may want to touch the bottom down here and observe the
Okay, but what about when we do that?
Here, just all you're doing here is observing. You don't have to do anything hard. You're doing observations. All right. Now, what do you notice right here? What's coming out? Steam or a gas, right? It's not necessarily water vapor, so you
I
can't.
know, but usually with fire.
So the way to test gas is to expose it to fire. That's why I'm here. You have to have a role here.
Maybe.
Yes, why don't you put the fire?
Was that smell it? Alright, so find out which station you have been to.
It's only happening where you can go.
Alright, you got about 5 minutes, guys. You got about 5 minutes.
No, the acid made the bacon so big.
Okay, so you saw what? What was your?
Okay, so have we done this one? This is
All right,
10?
here we go.
So we're
Now
going to do
listen.
basically the
So
same
it's
thing.
being exposed to the gas, right?
Okay, so I'm going to take my mask and light it.
So when it's exposed to the gas in here, it makes
So what kind of change?
So it makes
Okay, one. Okay, so that means it wasn't on. Okay, but what do I have when I do that?
all right. So you're going to tell me
So
this is what you saw. Feel it.
just make sure you just put
Still
which
warm.
one's which. So rip, burn.
Is this burning? This is burning?
The magnesium is burning.
Do you see fire?
Oh my goodness, no, no, no.
Decay?
No, it doesn't.
Yeah, it's getting.
We only want to put it in the test tube.
And that's our also increases.
That's our
chemical
discard.
reaction. Like we had a catalyst.
So put a little bit in
That's all
your
you're
test
doing
tube.
here.
Remember how much we said?
Okay.
You don't need a lot.
That's why you spin it, it dissolves faster. So the word dissolves is probably more accurate than decay or melt.
Alright, so
Some observations would be the magnesium is
Alright, so go to the station you haven't been to, which one have you not been to?
You're gonna have to like this.
Yep, you come over here. They're gonna jump off and wait for it. Alright.
Alright. And then if you say physical or chemical, chemical, right? And why is it chemical? And it created new, what's that word after the reaction?
Never used one of these.
New substance called product, right? And why did you think it was a physical change also? No, but it's made a new product. It's magnesium something.
Yes, ma'am.
Combined. This is just magnesium gas. Probably not magnesium gas, but it's maybe the magnesium changed into something else in here. The actual
If you're done at the station, move off to the side because there's a few people waiting. You go to some stations, they have it done.
What's our time?
10:49, so you got about 10 minutes.
It's been 10 minutes.
What time?
Yes. You can do it tomorrow. It's okay.
You just swirl it around.
We could all the ones except for like the big ones. We could test it.
We got. Oh, did you guys see this one? You did. All the observing ones.
Okay, but then you do this. Why is that?
We gotta do this.
Shannon, you would help her.
Whoa.
Alright,
I think we should have made it a.
are we gonna try it? We're gonna try it?
Number 5, real quick.
Hey, we're gonna try it real quick.
Hey, someone turn off the light.
Alright, turn off the light. Alright, what were my instructions?
I'm not looking at it directly.
Alright, so everybody wants to look out the side. Cheyenne, no look in the rest. Alright, so we're looking out the side. Where is it? So remember, this is gonna be number 5. Think about what's it gonna be, chemical or physical? No. Alright, Mr. K's ready.
Probably gonna happen real quick. There it goes.
Oh my snap. I want to look at it, but I'm not.
Don't look at it directly.
Don't go into the light.
The star is right here.
Okay?
I see the
Oh, you hit it.
Alright.
Oh my God.
It's going out.
Alright, get the lights for me, please. Alright, whoa.
We gotta wrap it up.
Alright, hold on. Ready? 1, 2, 3.
Wow.
That was interesting.
All right, I started off with magnesium metal.
What's that?
Is that magnesium metal right now? All right, so you have to put down what you observed. All right, and then you have to decide if that is a physical or a chemical.
Once you write that down, it is time for us to wrap up today. We need you to put anything that you, any liquids that you had in the beaker, in the discard beaker. Close any chemicals, please. And then you can just leave it setting on the lab station and we'll come back and take care of cleanup. We do need you to line up at the door.
Leave your goggles
Be careful
on the
of
desk
the water
also.
because we've unplugged it, but it is.
Oh my God.
5, 4, 3, 2, 1. Let's see your answer. Oh! You are looking. What this is, these are staples. Yeah! So what they've done is they have taken a stapler, they took the staples out, and they've just zoomed in on it. All right, let's do one more. Number 12.
These don't.
Number 12. Whisper with your partner on what you think this is. I'm going to tell you already, I didn't get this one.
I don't know what this is.
I didn't get this one at all.
Is it something that we don't know?
You know, I don't really know. I don't think so.
Like, well, this generation. It means something I don't see. I can't.
Yeah, I'm having my own brain. I'm not a partner.
It's kind of, I don't understand the clue.
Yeah. I understand this one.
Okay. 5,
Oh, no.
4,
Oh, shoot.
3,
But y'all gonna look at my answer.
2.
My answer is so true.
I gotta see this one. All right, everybody, show me your answer.
My answer is off. I put a side.
What is her answer?
Well, we have reached our plateau. We have reached where we had everybody have it right, and we're kind of doing, this is a cracker.
What?
It is. I know you don't believe it. I don't even believe it. What does that have to do with singing? This here, I don't know either. I don't know. I don't have a clue. I don't like it. So let's see about the next one. I think you'll redeem yourself. Number 13. Oh, you can do this one.
What? Oh, wow. I wonder what they are. Like, seriously.
Look at the picture and think of the patterns that you see here and where have you seen it? I know, when I saw it I thought, I know I've seen this somewhere. It's not my skirt, I'm going to tell you that already. Something else.
I'm guessing. Oh. Wait, I think I know.
I don't know. Look, we have to redeem ourselves and we're all going to have to get this one right. So I mean, you know what? I'm going to give you a couple more minutes because I want you to really get yourself together and really think hard. Whisper to your partner. Let's work together. Hey, girl.
There aren't so many hard.
But you know the answer. Five. Yes.
Yeah, I know.
Please, one person. 3, 2, let's see, 1. I was so scared. I have one. Thank you. Thank you. Thank you.
What was it?
A butterfly.
That's what I did.
Last one of the day. Number 14, and it says
Look, guys. Use the eyes that God has given you. Look at that right there. That's got something on there.
It's something that whatchamacallit.
Just call everybody in.
Nah, it's something that Shannon eats.
Oh. I said my
Five.
I'm so done.
4, 3, 2,
Come on.
1. 5.
Check.
Somebody said sour Jolly Rancher.
Exactly, it is a sour Jolly Rancher.
Oh,
Oh, that's what I need. Oh, thank you.
Rancher is right here.
how did we get that at a Jolly Rancher?
I thought it was a, oh my God.
Yeah, well, there are some flavors of Jolly Ranchers that make me go just, oh my, like watermelon. I don't know if you've ever tried sour apple. I love
Sour apple is disgusting.
Exactly what I had.
All right, so this is what I need you to do. This is what I need you to do. I need you to erase your board, please. And what I'm going to do is we're going to come by and collect the boards. We're going to come and get the dry erasure boards. Please put your wrappers to your candy on your table. Now, as they do this, I'm going to dismiss a group. And what I want you to do is I need you to get up from your table. I need you to go back to the back there, find your map. Now we're going to do it a little different today. We're not going to get on the floor today. We're going to try to do it at the table. I'm going to give you an opportunity to get that. You're going to work on that. I'm going to give you 20 minutes, and that's it, to finish this map today. Does everybody understand what we're doing? All right, boys, if you'll go back and get your map, please. Just leave everything there. Yes, ma'am.
Can we listen to music?
No. Not today. I'm sorry, babe. Yes, sir. All right, ladies, if you'll go back and find your map, please. You can move it where you're comfortable. Ma'am, can you go get your map?
Like, well, you went to the trash can. At least throw my stuff away too.
Seriously, my family cannot snap.
They do it to me.
No, I can't snap.
All right, sir, if you'll go get your maps. Sir, if you'll go get yours.
Snap a thing, I can't snap. My mom can't snap, so I can't.
I do.
What?
Y'all need to roll it out.
I do that because I did yesterday. I was mad.
Okay, I can't.
Go get your map.
Look, it just. Oh! I don't know. Let's go. Thank you, baby.
Just go get your maps.
That's right.
Chapstick. Boys.
I don't care if it's Jolly Rancher.
Boys. Go get your map.
Ow! I got slapped.
We told you to get a second one. All right, I'm going to release you in about a second or two. But before I release you, I want to do one thing first. Okay? Now, the first thing that I want to do is I want to kind of talk to you just for 1 minute. Okay? Just for 1 minute what we talked about yesterday. Now, if you remember from yesterday, yeah, please. We talked about this information right here. We talked about imaging. We also talked about aerial pictures. Remember that? We also talked about how aerial pictures are where you're able to see things that you would not be able to see on the ground. We also talked about satellite images. And then this is not what we talked about today. You give me just 1 second and then I'm going to let you go. This here is a form of a topographic map, kind of like what you're doing here. And if you see, these are in colors. We're not going to do ours in color today. We're just using one color and we're specifying for the South Carolina map. Now, The map that we're using, I want to make sure you understand. Why is this important down here?
Show the depth.
Does it show the depth or does it show elevation? I'm hearing two different things. Elevation. And yesterday, what did we do, ma'am, with our map when we got it, before we started putting clay on it?
We numbered
The areas, right? On which one was higher, which one are lower. And so today, what you're going to do is you're going to take that information and you're going to make your own map. So what you're wanting to do is, I have one more question. Is this going to be high at all off of your paper?
No.
Is this going to be the highest level?
No.
Or is this going to be the highest level? When I'm talking highest level, what do I mean about the amount of clay? Lot. So, do you see a pattern to this? What is the pattern, sir?
It goes like, it starts big, it goes smaller.
Kind of like a slope. Exactly. Remember what I told you yesterday. This picture of this map is where it's kind of like if you were blind and you couldn't see this map. You could feel your map and you could find the different elevations. Okay? So your goal in the next 20 minutes is to finish your construction of your map and have it completely covered today and have the elevations illustrated about the amount of clay. Everybody understand what we're doing? All right, get started.
I have a theory that is there anybody that's going to get off? Wait.
Okay.
Well, I'm going to set it because it's 15 seconds. All right, if you look at my timer on the board, oh yeah, I was so excited this morning when I found this timer, I almost jumped up and down. It's going to give you 15 minutes is all I'm going to give you. When that thing gets done and it gets down to 0, then it's going to shoot off and it's going to shoot off fireworks, it's going to make noise, and we are going to stop. Your goal is to keep your eye on the timer and make sure you get it done today. Does everybody understand? Yeah, ma'am. Okay, get started, please. You know what? I'm one of those. This is the thing. I worked on my last Sunday. And you have lines like that. I just couldn't do it. How more did you do that? Yeah, like you bought really? You know what I did? I used my finger. See that right there? What color do you think on that? And it was good job.
It's so quiet.
You know what? I think y'all gonna be done.
What?
How are you doing today?
Yeah. Anyway.
Sorry. That's fine. Thank you. So how much time is that? Better? I know it's kind of more difficult on the table, but I found last night pushing on my table was easier to flatten it out than having it like this. And that's why I thought it was so good. Because that carpet is like super.
It's like a week.
This is what I suggest. I'll give you a suggestion.